Hey, Bryce Carlin's here from Robotics Competition News. We're here at 2017 Worlds in Houston, and we're here at the Ruland booth to talk about some clamping collars with Chris.
Hi, my name is Chris Gumas from Ruland Manufacturing, and this year for First Choice we actually made a number of additions. So we added more collar styles. You can see all of the First Choice parts are available up here. The big thing we did was add colored collars, which gives teams the ability to better customize their robot. There's really no functional benefit, but they just sort of look cool on the robot, which we all know we're going for cool at first. So,
I think collars and like more advanced clamping collars are some of the most like underrated and underused methods of like power delivery, because there's like everyone's got those like single set screw collars used for like half-inch shafts, but there are lots of like more advanced and like very like unique and different ways and different kind of collars you use for a lot of different like more specific applications. So like what are you thinking on those lines, like more advanced things that you think first teams could benefit from?
So the most important thing with the collar is actually the screw. So the screw is going to be where the collar derives all of its holding power from. And if you have poor screw construction, poor kind of ratio of screw to pocket, if it's just not designed correctly, so if your screw is oversized or undersized, you're going to lose performance on the collar. We know one of the things that a lot of the first teams have struggled with is when they use the thinner collars, the screws strip out easily, and that's really because the thinner collars, they have such a thin wall and such a thin screw that you have to be it's very sensitive to the installation. So really you're supposed to be installing them with a torque wrench to the recommended seating torque. We know that that's not always available to first teams. So a lot of times a more standard size collar is actually going to be a better solution.
Okay. That's definitely good info. I know, at least on our team, or teams that I've seen, they use like the thinnest like black hex collars they can find, and it's just the screws strip out after like one season. They're just like worthless at that point.
And realistically, a lot of that comes down to weight. You're trying to save weight, so you're trying to use the thinnest, lightest weight components that you can. When it comes to collars, the weight difference between the really thin collars and the standard size collars isn't normally so different that it's going to impact the overall weight of the robot in any measurable way. So you can actually use the standard collars in place of the thin collars as long as you have the space for them.
Excellent. So some of the other kind of collars, one thing that I know our team struggled with is couplers. The ones that we used were just like weird, and like the screws were tiny and had like 8 screws on to stretch out very easily. What kind of like different coupler solutions do you have?
So it depends on what you're doing. One of the reasons that we offer 6 types of zero backlash couplings is so that the designer or the users can kind of select a coupling that matches their performance needs. Good example is an encoder. On an encoder, a lot of times you'll see just about anything. Sometimes you'll just see duct tape. Sometimes you'll see flexible tubing, which in some cases, if you don't want to be so fine with your positioning, those are actually workable solutions. But a lot of times you want something that's a little bit more accurate, has a little bit more sensitivity. So you'd go to something like a beam coupling. Beam couplings are great for encoders because they're flexible, yet they're still accurate. So your shafts don't need to be in perfect alignment, which we know is really challenging with an encoder, especially on a robot. And they could take a little bit of a banging too. So if you have a high vibration, there's not going to be any torque or really any speed going through them. So generally a beam coupling is going to be able to withstand the needs of a first season, if you will.
And for encoding, those are zero backlash, so there's no delay in power delivery?
Correct. All the couplings that we make are zero backlash. And a beam coupling is a good example of one where it has high windup, but in an encoder application, that's not actually a big deal. You're normally not positioning over such a small increment that the windup's going to make too much of a difference.
Okay, that makes sense. I think that's about all I have. Thank you so much.
Great. Thank you for stopping by.